Hi everyone, I'm Hanlin and I'm gonna do the question 2 of homework 5, so let's begin. So for the first problem, it tells to draw the region of fxy. So it tells that y is larger or equal to 1 and we have x larger than 1 over y and smaller than y. So we will have two boundaries. The first will be y equals to x, and because y is larger than x, so it is over this boundary, and we have y equals to 1 over x, and y is larger than y over x, so it is also over this boundary. So we will have this shadow area as the region of fxy, and they intersect at the 1, 1. So that's the region of it. And for the second problem, it tells to find A so that fxy is a valid joint density function. So it is a density function only and if only this integral at the area D of y over ax times y squared dx dy is equal to 1. So we could just calculate this integral first. So inside we'll calculate the integral of x first, and outside we'll calculate the integral of y. So inside for the integral of x, it is from 1 over y to y, and the y's range will be from 1 to infinite. So inside this the integral of it will be the ln x, because a times y squared is just a constant. So 1 over x is the derivative of ln x. And calculated, we will have 2 over a times the integral from 1 to infinite ln y over y squared dy. And inside is ln y squared is the derivative of 1 minus ln y divided by y squared minus 1 over y squared, and simply calculate it. Actually, the inside this integral will be just 1, minus 1, and we will have minus 2 divided by a times minus 1. We will have 2 over a, and it is equal to 1, so we will have a equals to 2. That's the value of a. So for the third subproblem, it tells to find and draw the density function fx and fy. We will just use the definition of marginal function. So fx equals to the integral from minus infinite to infinite fxy dy. And from this inequality, we will know that y is either larger than x or larger than y over x, depends on x and y over x, which is the larger one. So when x is larger than 0 and smaller or equal to 1, actually 1 minus x will be the larger one. 1 over x will be the larger one, so it will equals to the integral from 1 over x to infinite. And if x is larger than 1, x is larger, so the integral will go from x to infinite. And of course it will equal to 0 otherwise. So can we calculate it? It will equal to 1/2 when x is larger than 0 and smaller or equal to 1, and it will equal to 1 over 2x squared when x is larger than 1, and it is equal to 0 otherwise. So then we calculated the margin function of fy, still use the definition of it, and here it is from 1 over y to y. So it is equal to ln y divided by y squared when y is larger or equal to 1, and it is equal to 0 otherwise. So we will have these two figures. This is the figure of fx, and it is the figure of fy. And for subproblem 4, it tells to verify fx and fy are valid density functions. So to validate it, we just have to prove that the integral from minus infinity to infinity of fx dx and fy dy is equal to 1. So for the fx dx, here we can, it will be divided into two terms. The first will be from 0 to 1, and the value of it is 1/2. And the second is from 1 to infinity, and the value of it is 1 over 2x times 2x squared. So it equals to 1/2 plus 1/2, it is equal to 1. So we know that fx is a density function, or valid density function. And for fy, it is equal to from integral from 1 to infinity ln y over y squared. And from the sum problem 2, we know this is actually equals to 1. So yeah, it's also equals to 1. So we know fy is also a valid marginal density function. And that's all for this question 2. Thank you.